Hello, this video is going to show you how to find the sum of an infinite geometric series. Now this is a little bit different than what you had on Khan Academy. On Khan Academy, it was infinite series without the word geometric. The important part here for us is that we are actually looking at these very, very specific types of series, which is the geometric series. They're the ones that look like exponentials and can be written with the initial term times the ratio. And so I'm just going to do an example like this, n equals 1 to infinity. And we have whatever our first term is. And this is all stuff that should have been on Khan Academy. So if you still have questions or it doesn't make sense to you, you can always come to the class meeting. But it looks something like that. And the important thing here is that if there is a sum, if the sum exists, then the series, or the function, I'm going to say the series, converges. What that means is it basically, because it's exponential, it means that there's going to be a horizontal asymptote that it's going to get very close to as it goes from left to right. So it's going towards something. It looks something like this. If I was to graph it, it would look somehow like this. There would be some sort of horizontal asymptote that it's getting very, very close to as it's moving out towards infinity. And in your work, you're going to be looking to see if it converges or not. And the way that you know is if the infinite sum doesn't exist, then you say that the series diverges. So I say if the sum does not exist, then the series diverges. Well, how do you tell? You might be asking yourself, Miss X, how can I tell? What should I do? And the answer is, go look it up online. No, I'm kidding. So how we do it is, it's actually quite simple, and it has to do with this R, this ratio. And the ratio tells us whether the function looks like this, whether it goes up like that or whether it goes down like this. And if it's a decreasing, so like exponential decay, then we're going to have a sum, because as we go from left to right, we're going to have some sort of horizontal asymptote that the function gets very close to. Because remember, we're going to positive infinity this way. If the ratio, if it's something that's growth, exponential growth, then there's no horizontal asymptote up here. It's growing forever and ever and ever. And so we would say that the sum does not exist. And how you can tell if that's happening or not, because it can also look like this, or like this. This sum would not exist. This would diverge. A graph like that. Oops, it's not writing. This kind of graph converges. This kind of graph converges. And this kind of graph diverges. So these are the two graphs we're looking for. And so how we can tell, it's actually quite simple. It has to do with the absolute value of the ratio. If the absolute value of the ratio is less than 1, meaning it's a fraction, then you have a sum. Then the sum exists and the function or the series converges. If the absolute value of the ratio is greater than 1, then the sum does not exist. It DNEs and the series diverges. Unfortunately now, if you start yelling, the sum does not exist, nobody's going to be there to hear you. But I give you permission to yell it out loud anyway. And so I'm going to do a few examples, not many, because there's nothing else to it. That's all I want you to do with this. There's a worksheet attached to it, and what I want you to do with it is you're just going to go through and say if it converges or diverges at the beginning, and at the end you're actually finding the sum. And so for the first one, it looks like this. I have sigma, it goes from n equals 1 to infinity, of 20 times 1/2 to the n minus 1. And I just have to look at this ratio right here, 1/2. the absolute value of a half equals a half, and that is less than 1, which means the sum exists and the series converges. So I can say it converges. Now, if I wanted to find the sum, and keep in mind that you're only finding the sums in the second half of the worksheet. The first half, you're just writing converges or diverges. But if I wanted to find the sum, it looks like this. It's A1 over 1 minus R. I believe that is one of the things that you also have on Khan Academy. I believe that is one of the assignments you have, so this should be kind of reviewish. But if it's not, it's a very simple formula. A lot of students really like it because it's a lot nicer than the finite geometric series sum, which is a pain. Here's my A1, and I would write 20 over 1 minus a half. 1 minus a half is just a half. So I have 20 divided by a half, which is the same as 20 times 2, and that equals 40. So I'd write it converges, S equals 40. And that's all there is to it. I'm going to do 2 more examples. Here's another one. I go from n equals 1 to infinity of 16 times 1/3 to the n minus 1. If we were in class, this would have been part of the same day as finite geometric sums, and we would have done everything in one day. And this whole week would have been 1 week on everything that we're doing over the next 2 weeks. And you probably would have had to do this on your own and write the answer on the board. The first thing I'm going to do is check my ratio. The absolute value of 1/3 is 1/3. And so it's less than 1. Even if it was negative, the absolute value would still be negative. It would still be 1/3. It's less than 1, so I can say that it converges. And then if I want to find the sum, which you're doing only in the second half, so please read the directions, I can do that. 16 is my A1, and my ratio is 1/3. Be careful when they're negatives. This one's positive, but if it's negative, you wind up with a minus minus, which is a plus. And we get 16 divided by 2/3, which is the same as 16 times 3/2, which is equal to 24. And so that's my sum. It's 24. I want to look at one more problem. I'm going to turn the page. Turning the page. Ooh. Turning the page. And here's the last one. Whoops, there goes that one. I get the sigma from n equals 1 to infinity of 2 times 4/3 to the n minus 1. And so when I look at R, I have 4/3. The absolute value of 4/3 is 4/3, and that is greater than 1. If it's greater than 1, then the series diverges. You know, there's a whole series of books written about these kind of series. They made movies out of it. I think it was called Divergent. I think it was about infinite geometric series with ratios that were greater than 1. I'm pretty sure. I don't know. I haven't read the books or seen the movies. Maybe some of you have seen that and can tell me if I'm wrong. But if it's not really about math, then I think the person that wrote them is really missing out. Actually, let me do one more with a negative one that does converge. So let's say I have something that looks like this, and I'll use negative a half, something like that. I mean, wouldn't it be so much cooler if it was really about, you know, series? Then it would be educational and exciting. The absolute value of negative a half is 1/2, and that is less than 1. So this is convergent. Actually, converges. We don't say it's convergent. And then I can find that sum. I have more space, so I'm going to spread out. I get 3 over 1 minus negative a half. That's that negative a half. And so you have to be careful because I'm really saying 3 divided by 1 plus a half. Well, 1 plus a half is 1.5, which is the same as 3/2. And so I have 3 divided by 3/2, which is 3 times 2/3. These cancel out, and I just get 2. I hope you have a wonderful week. Good luck on your AP tests. I know a lot of you are taking them. If you have any questions, please feel free to come to our weekly meetings, which are Tuesdays at 3. That's right, Tuesdays at 3 or Thursdays at 9. And otherwise, you can also private message me or email me, and I'll get back to you as soon as I can. And I hope you have a wonderful week.